When you look at our catalog and you can see 8 or 9 different models of temperature controllers, how do I choose? The 210 series we say is for reactions 5 liters or less. Then you get into the larger ones, the 250s, the 260s, the 270s. And therefore reactions up to 22 liters. You can look at the safety controllers, the 270. Can I use a more standard 210 controller that doesn't have sophisticated features of a 270? How do you decide? The first thing I would think is don't get confused with volumes. So when we say that a 210 can run a reaction up to 5 liters and a 260 can go up to 22 liters, that's the maximum power. Both of those controllers, which is probably more important, they can run the reactions at 100 milliliters, 10 milliliters. Both of those controllers have our power control computer. The choice isn't between a J-KEM temperature controller and a controller by another manufacturer. It's between success and failure. You have a controller that can regulate a dynamic process to 0.1 degree, and you have another controller that can't regulate it to 10 degrees. A really critical feature of our controllers. And this is how J-KEM, frankly, became the premier temperature controller manufacturer for the research industry, is our power control computer. You can look at our controller and you can look at another controller from a different manufacturer, and they look similar. They're both going to have a digital meter. They're both going to have a power cord. They're both going to have a place to plug your heater into. The difference is, in our controller, we have the same PID meter, but we also have a power control computer. The PID meter is the interface to the user. It gives you buttons to punch in your set point. It shows you what the current temperature is. But what's actually regulating power to that heater is our power control computer. That control computer is reevaluating the power output to the heater 2,048 times a second. We guarantee that we can maintain temperature to 0.1 degrees. Our power control computer has the sophistication to do that, and another controller just simply cannot. And so I think the choice isn't between a J-KEM temperature controller and a controller by another manufacturer. I think it's between success and failure. You have a controller that can regulate a dynamic process to 0.1 degree, and you have another controller that can't regulate it to 10 degrees. And so really the 210, we're saying it has the range of 100 microliters up to 5 liters. The 260 would have the range of 100 microliters up to 22 liters. So you don't lose anything by going to the 260 as opposed to the 210. But there are a lot of chemists who never use anything larger in their life than a 500 milliliter or 1 liter flask. And in that case, the 210 is smaller, and most of the time in chemistry, small is beautiful. The 210 is smaller. It's exactly what they need. Once you decide whether you need one of the smaller research controllers or one of the more powerful research controllers, the next thing to consider is, do you need a timer? For many of the temperature controller models that we offer, you can get it with or without a timer. For example, you can get just a 210, or you can get a 210 timer. You can get, in our higher power controllers, a 250 or a 260 timer, which are very similar controllers. Another consideration is how many independent temperature control channels do you need? For example, the Model 210 has one, which is a typical reaction setup. It's one temperature controller, one reaction. But I've never met a chemist that had too much hood space, and so quite frequently, researchers need to run 2, 3, or 4 reactions in a hood. And you could take 4 210s and you could stack them on one another. But of course, the number of cords and the height of that stack of controllers gets to be unmanageable. And so we offer several models that are 2-channel, the Apollo and the Gemini, for example. For someone who really has a need for a multi-channel control, we offer a quad controller. Basically, it's just 4 210s built into a single cabinet. It's just a matter of practicality. If you're going to set up 4 reactions in your hood, or even 2 reactions in your hood, the Gemini, for example, is functionally a Model 210 and a 210 timer built in the same cabinet. The quad is 4 210s. It's just a matter of hood organization. It's a matter of simplicity. It's one power cord. It's just a matter of cluttering up your hood. If you want to remove some of the clutter of setting up 2 reactions with 2 temperature controllers in your hood, then a Gemini, for example, is a good choice. It's one controller, it's one instrument with 2 temperature controllers built into it. But another consideration is that there are times when you would want 2 separate controllers. For example, if on Monday you're going to run 2 reactions in one hood, well, you'd set up 2 210s in that hood and you'd run your reactions. But of course, with 2 210s, you have the option on Wednesday to set up a reaction in this hood and another reaction in the other hood. So it really is just a matter of how do you work? What's the nature of your research? The last consideration I'd make is what special features do you need in your controller? All of J-KEM's controllers have built-in over-temperature circuit, but some of our models have uniquely safe over-temperature circuits. The Model 250, which has 2 heating outlets for large reactors like a 22-liter heating mantle, but it also has a cooling outlet. And that cooling outlet can be used to turn on cooling fans or maybe a water pump to pump water through a cooling coil, or it can even turn on a small circulating chiller. The Model 260 actually has a separate over-temperature circuit, an independent circuit. And with the 260, you can program it to say if you go over temperature one time, turn off power, and you're done. You don't get to restart heating until you manually reset that controller. Typically, with our temperature controllers, if you go over your set point temperature, heating is discontinued, but heating resumes when you come back below the set point temperature. But there are situations where a single overshoot of the set point is not acceptable. And in those cases, something like the Model 260, where you have an optional circuit that you can turn on, and it says if you go over temperature one time, you turn off and you're done until I come back in and manually reset that controller. So with the different models of controller, you can decide what happens when you go over temperature. If you go over temperature and then it cools back down, do you want it to resume heating? Or if it goes over temperature, is it just absolutely turned off? It will not resume heating until you manually reset the controller. Another consideration is for people who do process scale chemistry, large scale chemistry. When you move to large scale chemistry, you need 2 things. You need controllers that have more power and maybe even a little more sophisticated in their heating. And you need controllers that have inherently built-in safety features that aren't necessarily needed when you're doing a 100 milliliter reaction. And so we have a series of high safety controllers. For example, there's our Model 270, design of which has 2 independent controllers in the same cabinet. There is the temperature control meter in the cabinet, and there's also an independent backup controller. The important thing to understand is that the set point controller and the backup controller share absolutely nothing in common. They're 100% independent of one another. They're 100% redundant. So when you set up a reaction, just like a normal controller in the set point meter, you'd enter the desired temperature. In the safety controller, the backup controller, you'd enter what you consider your high temperature cutoff to be. And now you have both the primary temperature controller and an independent backup controller watching the exact same reaction. And if any point they disagree, if they disagree on what the set point is, or if one of the 2 controllers' thermocouples go bad, if they disagree at any point in that heating process, both of those controllers have the power to shut that reaction down and keep it off until you manually reset the controller. So the key feature in what we would call our line of safety controllers is that you have 2 completely independent instruments in a single cabinet monitoring that reaction, which we believe should be a required safety feature if you're going to either run a very large-scale reaction or you're going to run a reaction unattended, especially overnight. The importance of having both a primary set point controller and a backup controller in the same cabinet is if one of the two controllers fails, the other controller takes over. If one of the two thermocouples fails, the other controller takes over. At any point when either of the two meters, either of the two sets of electronics inside, either of the two thermocouples fails, anything in that entire system fails, you have an independent backup that will take over and shut the reaction down. There's other safety features we offer, such as the loop break alarm. It guards against two heating accidents. It's not uncommon for a chemist to set up a reaction. They enter a set point, for example, of 80 degrees, and then they forget to put the thermocouple in the solution. They leave the thermocouple sitting on the bench and they walk away. Well, the problem with that situation is you've just entered a set point of 80 degrees, and so the temperature controller is going to do what it's supposed to do. It's going to heat. But the thermocouple's on the bench, so there's no feedback of that reaction heating up. So the temperature controller heats more. But there's no feedback again, and so it does what it's supposed to do. It heats more, and it heats uncontrollably. What the loop break alarm does, it constantly monitoring the temperature change. It knows that your set point is 80 degrees, and it will give that reaction, just for example, 5 minutes to begin to heat. And if it doesn't see any heat in 5 minutes, it turns the reaction off, knowing that there's an error. It also guards, for example, you're heating a reaction overnight, 3 o'clock in the morning, a flask breaks, or the thermocouple falls out of the solution. Either way, it was at your reaction temperature. It's just gone to a lower temperature, and now again that 5-minute clock starts. Your controller would start to heat in both of those situations. But if the loop break alarm doesn't see a change in temperature in that 5-minute span, it turns the reaction off and declares an error. We've also seen it valuable in cases where you're doing a reflux reaction. You lose cooling water. Well, if you boil away enough of your solvent, now the thermocouple is no longer in solution. It's just in the air of the reaction, and its temperature will go down. And even in that case, the loop break alarm will turn off heating. Basically, you have to stay at your set point, and if something disrupts that process, it just monitors, is my heating system intact? If I put electricity on this heater, do I see a change in temperature? And when the answer to that question is no, it turns the reaction off. When you look at the entire line of J-KEM temperature controllers, whether we're talking about our economy series, whether we're talking about our research grade controllers, or whether we're talking about our high safety or high power controllers, fundamentally, they all share the most intelligent PID temperature controller on the market. Then, starting with that foundation of the PID controller, we add other features. Certainly the most fundamental safety feature of any temperature controller is you get the temperature you ask for. There's no other safety feature that's more important than saying I want to heat my reaction to 80 or 90 or 100 degrees. If you ask for 100 degrees, you get 100 degrees. You can punch in 100 degrees and you can walk away. J-KEM also has an economy controller, our Model 150. And by economy, you shouldn't think unsophisticated. What we mean by that is the Model 150 does not have the power control computer, which all of our 200 series or our research line of temperature controller has. The power control computer is useful when you're heating volumes lower than a liter, especially when you get down into the low milliliter range. But there's a lot of chemists who do work on 1 liter and above, or a vacuum oven, or a hot plate, or, a larger device. And when you're on those larger devices, then you don't necessarily need the sophistication of our power control computer. You just need a good PID controller. And that's what our Model 150 is. Here's the key difference between our Model 150 controller, which is just the PID controller, and our research grade controllers, which have the PID controller plus our power control computer. The key difference is if you were heating a liter, the controller has time to watch it heat. Because the volume is so large, it's going to require so much heat, it's going to heat slower. But if you're heating a milliliter in a 5 milliliter round bottom flask, you don't have the time, you don't have seconds to look at the slope of that heating curve. That 5 milliliter heating mantle has enough power to boil your fluid and melt the flask. In a situation like that, our power control computer adjusts the power to that heater 2,048 times a second. The heating applications that the Model 150 would be used for, you don't need that. Then there's our Model 410, which is used typically with a heater such as an oil bath. There are some oil baths that are rated at 20 or 40 or 60 volts. And in that case, you need a controller that regulates low voltage, that it can vary the voltage of the output to control the power that the heater produces. There's some type of heaters, such as oil baths, that have voltage limits. They can't be used with a 120 volt controller, for example. Small oil baths might have a voltage limit of 20 or 40 volts. And so we make a Model 410 that regulates low voltage heaters like oil baths. The last thing to understand about J-KEM is we don't just make the standard temperature controllers that you can see in our catalog. We make custom controllers. We will make the temperature controller that you need for your application. We have had people who needed, for example, a cell phone dialer on it. So if something went wrong with reaction, it called their cell phone at 2 a.m. We've put on custom safety features. We often run into clients who want to control both temperature and pressure. So we've put in a single unit a temperature controller, the flask, and a vacuum or a pressure controller for the reactor. We can build that into the same unit. Often we have customers who have really very high power heaters. We shipped a controller within the last month that was 208 volt output, 3-phase current, 80 amps, 22,000 watts. And what's important about these custom controllers, when you come to that wattage, when you're going to put a temperature controller on a heater with that much power, you need safety. That controller was NRTL approved. That controller had both a primary and a secondary backup. That controller was built with 20 years of experience. When you are going to put that kind of power into a heater, that's what you need. We've made temperature controllers for applications that have 9 independent channels. All 9 channels were data log. We have software which can both data log, graphically display the data, and it can log the data in a GMP compliant format. USB communications is standard in our controllers, and the data logging software is free. I think it's important to understand that J-KEM isn't a company of engineers that make electronics. We are research chemists. Our background is research chemistry. We made controllers so that we could use them in our research. So the logo on our name is Instruments for Science from Scientists. But that's literally true. All of our background is in research chemistry. The company J-KEM started making temperature controllers. But just as our motto is we're scientists making instruments for science, people called us and asked us for other products. And as time went along, we make precision vacuum controllers. We make precision pump systems. We make custom robotics. Everything in J-KEM was research-driven. All of the products we offered, they really resulted from a conversation of a researcher who called us, who had an idea, who needed an instrument. And there are so few companies anymore that will talk to that person, that a researcher can call and talk to an engineer and say, I need one of this. I need this instrument to turn that on, to do this. I need one. And J-KEM is that company.